Alright, in the next two videos we're going to cover Chapter 2, Section 7, and the topic is inverse functions. Let's see here, over these two videos we'll go through these 5 bullet points. Verify that functions are indeed inverses, find the inverse of a given function, use the horizontal line test to determine if a function has an inverse. We'll use the graph of a one-to-one function to graph its inverse, and find the inverse of a function and graph both functions on the same axes. And again, a lot of people might wonder, okay, what exactly is an inverse function? Or inverse functions are two functions and one of them will undo what the other function did. Like if I say f of x is x squared, okay, what undoes squaring something? Well, that would be the square root function. So squares and square roots are inverses. If I compose the functions and I put the squared under the square root symbol, the square and square root would cancel and an x would come out. And then the other hand, I could put the square or the square root into the squaring function, and the radical squared will cancel, and I'll just get, again, the answer of x. So one function that undoes what the other function did, those functions would be inverses of one another. And here's our book definition. Let f and g be two functions such that f of g of x is equal to x for all x's in the domain of g, and g of f of x is also equal to x for all x's in the domain of f. The function g is the inverse of the function f and is denoted by f inverse. And we read that out loud as the words f inverse. It's not f to the negative 1 power. Thus, f of f inverse of x equals x, and f inverse of f of x is equal to x. The domain of f is equal to the range of the inverse and vice versa. And it seems like we got a great question here. Let's see. Is the minus 1 in f inverse an exponent? The notation f inverse represents the inverse function of f. The minus 1 is not an exponent. The notation f inverse does not mean 1 divided by f. Those are not the same thing. Okay, example 1. We're going to verify that two functions are inverses. So it says show that each function is an inverse of the other. So let's see, I'll divide this up here. On the left, I'm going to do f of g of x. I'm going to compose the functions with g as the inner, and the inner function g will go into the f function. So I like to start these by copying the outer function without the x. So this was 3x plus 2, or 3x plus 2. And now I'm taking the x out, and I'm going to replace it with the entire g function. X minus 2 divided by 3. And let's see what happens here. Well, this is a 3 over 1. On the diagonal, the 3's cancel, so I'm left with quantity, x minus 2, and then plus 2. Well, the minus 2 plus 2 cancels, so I'm left with x. F of g of x is equal to x. And now I'm going to compose them in the reverse. G of f of x. So g is the outer function, and here's my g function. It was x minus 2, all divided by 3. But I'm going to take the x out and replace it with the other function, f. So that's 3x plus 2 goes in for the f function. Well, the plus 2 and minus 2 cancel, so we're left with 3x over 3. And the 3's cancel. So g of f of x is also equal to x. And we verified that each function is the inverse of the other. And if we think about, the order in which we would do our steps, if we're starting here with the x, the first thing we're going to do is multiply by 3, and then we're going to take that value and add 2. So for f, we're going right to left or left to right here. First step, multiply by 3 and then add 2. So now for g of x, we want to reverse the steps and reverse the order. So instead of adding 2 as our second step, we're going to subtract 2, the exact opposite of it. And then in the first part, f, we multiplied by 3. So what undoes multiplying by 3? That would be division by 3. So subtract 2 and divide by 3. F inverse undoes the changes produced by f. So in example 1, we were given two functions and we showed that one was the inverse of the other. How would we find an inverse given one function? So the equation for the inverse of function f can be found as follows. Step 1, replace the f of x with the variable y in the equation for f of x. Step 2, interchange the x and the y, just reverse them. Step 3, solve for y. If this equation does not define y as a function of x, the function f does not have an inverse, and this procedure ends. If this equation does define y as a function of x, the function f has an inverse. So if f does have an inverse, we replace y in step 3 by f inverse of x. We can verify our result by showing that f of f inverse of x is equal to x, and f inverse of f of x is also equal to x. All right, find the inverse of this function. F of x equals 7x minus 5. Well, step 1 said replace the f of x with the variable y. Y equals 7x minus 5. Step 2, replace or switch the x and the y. So I'm just going to replace this y with an x, and the x gets replaced with a y. Step 3, solve for y. Well, let's see, I'm going to add 5 to both sides. 7 plus 5 equals 7y. And then I'm going to divide both sides by 7. So here these cancel, and I get y equals x plus 5 over 7. And step 4, I believe it was, replace y with f inverse. So f inverse of x equals x plus 5 all divided by 7. And there we go, 4 easy steps. In step 1, replace this with a y, switch your variables x and y, solve for the y variable, replace y with f inverse of x. All right, here's a different one. Find the inverse of this function. Again, easy steps. Step 1, replace f of x with y. Y equals x cubed plus 1. Swap the variables. Step 2. So now it's x equals y cubed plus 1. Step 3, solve for y. Let's see here. First step, I'm going to subtract 1 from each side. Y cubed equals x minus 1. And now take the cube root. Y equals the cube root of quantity x minus 1. Final step, replace y with f inverse. F inverse of x equals the cube root of x minus 1. And I think that's it for this video. Yeah, we got 3 practice problems here for you to try. So pause the video, answer the questions, and then fire it back up and see if you got them right. All right, show that each function is an inverse of the other. I like to start with f of g of x. So the g function is going to go into the f function. So I'm going to copy this f function without the x's. It was 4x minus 7. But now I'm going to replace this x with the entire g function. X plus 7 all divided by 4. Well, let's see, the multiply by 4 and the divide by 4 cancel. So we're left with x plus 7 minus 7. And of course the plus 7 minus 7 cancel. So f of g of x is equal to x. And now we compose them in the other direction. g of f of x. So now f is the inner function going into the g function. So let's see here. I'm going to replace this x with the entire other function. So it's going to be something plus 7 all over 4. And I replace that x with 4x minus 7. So let's see, the plus 7 minus 7 will cancel. So we're left with 4x over 4, and the 4's cancel. So we're just left with x. G of f of x equals x. And we've shown that they are, in fact, inverses. Here's a function, find the inverse. All right. Step 1, replace f of x with y. Step 2, switch the variables. X equals 2y plus 7. Step 3, solve for y. So, see, I'm going to subtract x from both sides. And now divide by 2. I'll replace y with f inverse. F inverse of x equals 7 minus x, all divided by 2. Oh, and why didn't you stop me? I made a little mistake. So we're going to back up to step 2 here. Yeah, right here. Solving for 2y, it would be x minus 7, not 7 minus x, x minus 7. I'm just testing you to keep you on your toes there. All right, and then we divide by 2. So again, step 4, replace y with f inverse of x, and that's equal to x minus 7, quantity divided by 2. All right, one more to go. Checkpoint 3. We're going to find another inverse function. So, step 1, replace the f of x with y equals, now it's 4x cubed minus 1. Step 2, switch the variables. Now it's x equals 4y cubed minus 1. Step 3, solve for y. I'm going to add 1 to both sides, and that's going to be x plus 1. I'm going to divide both sides by 4. That's equal to y cubed. So when I cube root, y equals the cube of x plus 1, that quantity, divided by 4. And that's our inverse. All right, handful of problems to try tonight.